Okay, these are problems from last Friday, and right now last Friday is the 16th of February in the year 2017. So here we go. This problem number 2, okay, what page number were we on, folks? Huh? What was the page number that we were on? Your homework from the weekend? Page 826? Oh yeah, it was in the back.
Oh Lord.
876. Okay. Page 876, we were in one of the appendices, and that was giving you some background or give you some practice problems on doing what you're going to see right now. Let's triple check that. Appendix A for Chapter 10. 11. Yeah. Okay, good. Yep, that is exactly where we should be. Okay, so this is number 2, and here we are starting with moles of calcium carbonate. So let's check it out. What's first fraction have to be when we do this calculation? Given over 1. Got it. 12.5. They always start the same, don't they? Moles of calcium carbonate over 1. All right? Now, we're trying to get formula units. What ball game is that? Is that the Almo number, or is that the periodic table? Particles. Almo. Good. Okay, so the Almo number equals 1 mole. Always, right? No matter what the particle. Oops, let's make this carbonate, CO3. Okay. So what do we have to have on the bottom of that next fraction? Moles are the particles. Why do we need moles on the bottom? So they will cancel. They will indeed. Okay, and this is calcium carbonate. And that's calcium carbonate particles, or we could call it formula units. Not formula units. This would be a molecule. No, calcium carbonate is an ionic compound. So this is a formula unit. All right, and the Almo number is on top. Is that what we do? Huh? Sure. 6.02 times 10 to the 23rd calcium carbonates. Particles. And this would be formulas. No. So the formula unit, it's a particle. What do we call it? Sorry, I went brain dead. Yeah, this is a formula unit as opposed to a molecule. Formula unit because it's an ionic compound. All right, now what we have to do is there anything we can cancel yet? What can we cancel? Moles, good. Moles of calcium carbonate. So I'm going to cancel those guys out. And now I have a calculation that's pretty simple. I am going to leave out, and this is what I recommend you do. I've seen too many students that know how to do powers of 10 on their calculators that when they got to a test, they'd always get them wrong. I think it's partially because they just didn't understand what they were doing. They could put the numbers in, but they didn't really know what it was they were doing. So I would like to recommend that you do it this way. I'm going to put in, and get out your calculator and do it with me. If you're at home, stop the recording and go get a calculator. All right, I'm putting in 12.5 times 6.02. Well, what about the 10 to the 23rd? Forget it for now. Okay? So my number's going to come out on my calculator, 12.5 make sure I put it in right, times 6.02. I come out with 75.25. Do you guys come out with that? 75.25. Okay, so we get, and this is going to be an equal sign here, and I'm continuing it down below for the right side of the equation, 75.25. And this is going to be what unit? What's our unit? Okay, this is formula units. So this is also got to have the power of 10 now, so I'm going to put that in. 10 to the 23rd calcium carbonates, and those guys are our formula units. And now, that's kind of my answer, except I'm not in scientific notation. So I want to get into scientific notation. So what would I have to do with my decimal that's right here? Move it to the left. How many? 1. Okay. When I move it to the left, what does that do? Increase or decrease the power of 10? Increases it. Good. So I now have 7.525 times 10 to the 24th calcium carbonate. Formula units. Okay? And now let's work on the sig figs just for practice. The sig figs that you see right now are handled here and here. How many sig figs in each place? 3. So we can only have 3 in our answer. So if we round this to sig figs, we're going to take this 5 right here, and we're going to round up the 2 that's next to it to give 7.53 times 10 to the 24th calcium carbonate, not CO4, CO3, CO3, and that's our final answer, right there. Okay. See, that's what the book is saying. 7.53. So, we're good on that. Do we have any questions here? This isn't really too bad, is it? Yeah? Okay, 12.5. 1, 2, 3 non-zero numbers. Okay, it's okay. Same thing happens to me. Okay, here we have 1, 2, 3. This 0 is captured between 2 non-zero numbers, so it counts. Okay, it's the trailing zeros that sometimes count, and the leading zeros that never count. Okay, so there we are for that guy. Let's go. Go on. Yes, that's all right. It would really be best if we did. That was a good clarifying question. I really should at this point in time. Later on we won't, but for right now, why don't you abbreviate it form unit? Save you a little bit of writing. But yes, that's a formula unit. If it's not an ionic compound, we would call it just a molecule, right? So the ball game for those guys are both the same anyway, right? Yeah. Okay, let's go on and let's try. I'd like to clear this out and do it from scratch, and let's see how this guy goes. It's okay to show the answer. I don't care about that. We'll come to that answer and then we'll show it at the end. All right, what do I do? What's first? Given over 1. Okay, 4.59. It's always the same. Isn't that nice? And 10 to the 25th silver atoms. Again, the atoms part we'll leave off later, but for right now it's a good idea to put that in. And I don't know if these guys are connected. Yeah, they're all connected. Ah, nice. I'd like to separate this just a little bit. There. Okay, silver atoms. And that's over 1. Same color. That's all right. And now, what's our second fraction have to be? What gets unit formula atoms, which is a particle? What gets my particles into moles? Because we're trying to get moles. 1 mole of silver. So we got to have particles on the bottom, don't we? Yeah, and the particles goes with a big number, right? Mr. Avo? And his famous avocado sandwiches. Avocado? No, whatever. 6.02 times 10 to the 23rd, and this is silver atoms, right? That's the particle. And on the top we have 1 mole. Yep, just like you said, of silver atoms. So, can we cancel anything? We can cancel silver atoms, can't we? Here and here, and silver atoms here and here. And now mole is on top, but the particle that we're dealing with is silver atom still. Okay? So it's moles of that particle, which is silver atoms. Okay, now we have the interesting thing with the powers of 10. Isn't that sweet? Okay, but let's do it like we did with multiplication. I'm going to get out my calculator now, and I'm going to put in my 4.59, and I'm going to be dividing by 6.02. Everything on the top is always divided by everything on the bottom. Okay, and we do it one number at a time. So if there's a lot of numbers at a time, you can just do a whole series of fractions, like 5 long, and you just keep going. We put in the guy that's on the top, and we divide it by the first guy that's on the bottom, and we go back to the top for the next number, and it's a chain calculation, which really works nicely. For right now, this is fine. You don't need to know anymore, and it would just be confusing to do anymore. So, here we go. And now we're going to get that number. When I hit the equal sign, I get 0.762. And 0.762, what is that? Yeah, what is it? 7.62. What is it? It's moles. Yeah, this is moles. I'm putting this way over here because I've got to put some stuff in between here. This is moles of silver atoms. And then in between, I'm going to do my power of 10 calculation. And so I've got 10 to the 25th. I'm going to do it like this. This is a little weird, but I think it's nice because it kind of ties it all up in a nice little package here. 10 to the 25th is on top, and 10 to the 23rd is on the bottom. Okay? Now, I've got to deal with this guy first. We need to do this in scientific notation, right? Yeah, let's get the power of 10. Let's go ahead and do the power of 10. Scratch that. Get that guy out of there. And then power. Let's go Control Z on the computer, and that'll get him out. Okay. Let's go ahead and deal with that power of 10. 0.762, oops, not 32. 762 times 10 to the what? What do I do with powers of 10? We're going to subtract when we divide, right? Power of 10s get subtracted. And when we multiply, what do we do with the powers of 10? Add. Okay. So this is 10 squared. But I'm not in scientific notation. Whatever will I do? Oh, move the decimal. Great thought. Is 1 enough? Yes. It is, most definitely. Okay, 7.62 times 10. Now we have to adjust that power of 2. So we move to the right. What happens to the power of 10? Does it go up or down? Down. Okay, it does go down. And so this is 10 to the 1. And then I can move these guys. Wouldn't you love to do this on your homework? Yeah. Okay. And that's my final number. And that's what we should see behind the box. Okay. And this is not in scientific notation. That's the number that I got from the textbook in their answer thing. So, isn't this the same number though? 10 to the 1 moves that decimal 1 to the right, which gives you 76.2. The only reason I did this was to keep you in scientific notation. Okay? But it's the same number. One more calculation. I'm just going to do this really quick. I'd like you at home to do the calculation ahead of me and see if you can stay ahead. If you can't, stop the recording so that I don't get ahead of you, because you will get far more out of this if you do it on your own. So here we go. Given over 1, 1.25 times 10 to the 24th, and this is formula units of calcium chloride, over 1. And now we're trying to go to moles. So from formula units to moles, we've got to use the Avogadro number, right? And the Avogadro number is going to be what on top and what's going to be on the bottom? Moles or particles? Okay, so our 6.02 times 10 to the 23rd times 10. Yeah, I thought that was going to happen. We're going to have to stop the recording a second because I'm working on an old smart board and I had to get my board realigned, which is why I took a little break. I also changed a couple of things. I was advised by one of my students that this number was a little off. It was 1.25. The way I wrote it down in the book has it as 1.26. And so I fixed it here as well and finished off what we do in setting up this calculation. So the next thing we want to do is we want to divide the 1.26. I can find my calculator. Here it is. Okay. We're going to put in 1.26. We're going to divide by 6.02. That will give us, what do you all get? 0.209. Is that what we're getting? Yes. Okay, so I'm dividing the 1.26 by the 6.02, and that gives me the 2.09. And now, oh look, how interesting. I had my power of 10 wrong here, and I didn't fix it. So this is actually 24. I hope that's what's in the textbook. If it's not, it's too bad. And now, like before, I'm going to do this guy like this, a little bit differently than I showed in the last one. I have I have 10 to the 24th on the top of the fraction, and on the bottom I have 10 to the 23rd. And when I divide, I subtract the exponents, right? And so this becomes 10 to the 1. And this is 0.209 times 10 to the 1. And this is formula units. And this is calcium chloride also. All right. Now we have one little thing to do. How do we fix it into scientific notation? Huh? Move the decimal to the right. What does that do to the power of 10? Power of 10 goes down, so this is 10 to the 0. Remember, powers of 10 move just like the number line. The number line, with this at 0, this would be the negative, and this is, no, backwards. This is the positive, and this is the negative. And so, as the number increases, it goes more toward the positive, and as the number decreases, it goes more towards the negative. And if you have a number line picture in your mind, that helps when you're doing that kind of picture, or that kind of calculation. So we've got everything set here, and we've got our formula units, calcium chloride formula units. Let's get that. Oh, that's okay. Calcium chloride formula units. And there I am. And oh, yeah, okay. And this is moles. Moles of. Moles of calcium chloride formula units, and I got the moles up in the top okay. I just left it out down here. And so we've got 2.09 times 10 to the 0, which is the same as 2.09. I'm putting it as 10 to the 0 to keep you in scientific notation, and I hope you all found this helpful. Thank you for watching. Sorry it's so long.